Dot plots and stem plots are great, but what if we had 500 numbers that we had to graphically put together? Do anybody want to do the stem plot for that or the dot plot for that? Plus it can get messy. Histograms are good all-in-one, especially if you have a lot of numbers to graphically represent quantitative data. Just to see where we're going, open up your book to page 50 and look at the bottom, and that's what it's ultimately going to look like right there. That is a histogram. Page 20. Page 20. Kind of looks like a bar chart, doesn't it? Like the ones we have around the back, except they're connected. Bar charts, remember, were for categorical data, where on the bottom we have different categories, like the ones around our room, say Elk Grove High School versus everybody else. In a histogram, the bottom is represented by a number line. Okay, they aren't categories down there anymore, it's an actual number line, and we're going to draw rectangles on those number lines. All right, so how do we go about creating a histogram? We're going to use that test data that I gave you before. It should be in your list 1. If you don't have it there, get it in your list 1 as quickly as possible. I'm going to add 6 more test scores. There was actually 36 students in that class. So let me add 6 more. So in list 1, add the number 38, 37, 57, 64, 62, and 59. So you should now have 36 total scores in there. You might want to sort them again too, because we're going to be using that data. Okay, the first thing that we're going to want to do is to create a distribution chart, much like we did before. Do you guys remember the first time we did this for those test scores, what we had to put over here? What did we do?
Gender.
No. We did down for the categorical. Now this is the actual test scores. What did we put over here? Remember what we did? Look in your notes. What did we put over here? What's that? Yeah. Did we put the actual scores here? Like we put 22 and then 38, 30. We had to put all of the different test scores over here in this column. Remember how long that got? I told you I was gonna show you an easier way to do that. Well, that's today. What we're going to do, rather than put the individual scores over here and count how many there are, we're going to give ranges. And we're going to say, okay, we're going to create a range. It's called a class. And we're going to say, I don't know, 20 to 30, and 30 to 40, and 40 to 50. And we're going to count how many of the test scores are in that range, that class. That's a lot easier than writing every single different number down that comes up. We're going to capture them in classes. Now this is the hardest part of creating a histogram. How do I create these classes? First of all, I want them of equal width. I don't want one class to be, okay, I'm going to have all the scores between 20 and 70, count them all up, and then all of them between 70 and 80. Well, wait a minute, I'm going to have a whole bunch more here just because I had a bigger width. Okay, I want to make sure these are all equal widths when I count them up. All right, so your book says if you're going to do a histogram, you're going to want at least 5 of these guys. If you look at page 20, that one, they must have done 6 different classes. As a general rule, I heard this someplace, I don't know if it's in our book, if you take the number of values that you have, then we have 36 test scores, and you take the square root of it, you would maybe want to round 6 classes. Now I'm going to break that rule right now. I think I'm going to make about 10 classes. Okay, so it's not a hard and fast rule, but it just kind of gives you an idea of how this will make the picture look the best to answer these questions. All right, now, when I thought about this, I could go by 10s, I guess, but then I thought about these are test scores, right? Wouldn't you want to know the A's and the B's and the C's? So I'll break them up by 8s. You know, like 72 to 80 is an A, and 64 to 71 is a B, and so on. So that's how I'm going to create my classes here. Now I know the numbers, the scores range from 22 to 81. So I need to make sure I create classes that are going to contain all the test scores. So going by 8s down from 80, I guess the first class is going to be 16 to 24. And then the next class would be 24 to 32. 32 to 40. 40 to 48. 48 to 56. 56 to 64. 64 to 72. 72 to 80. And then I got to include that crazy 81. I don't know how that happened. So I'm actually going to create 1, 2, 3, 4, 5, 6, 7, 8, 9 classes. I'm going to have 9 rectangles on my histogram in a second. Now I've already made a horrible mistake here. Not, you think you know what it is?
Because what if you have 124?
Perfect. What if the score was a 24? Which class do I put it in? You have a problem there, right? You can't do it that way. So I'll show you kind of a cool trick. I'm going to say 16 to less than 24. So that's gonna go 16 to 23.9999999. You know what I'm saying? We'll go in there, but 24 will go in here. That's a great strategy. So let's go ahead and put little less than signs in there. So now everybody's got a home and only one home. All right, now we need to count how many of the test scores are in those various classes. So somebody help me out if you got them sorted. You could help me out with this. How many were in here? There's just one. How many were in this?
0.
Oh, should I then erase that whole class? And no, I want to see that gap, right, when I do. What about here?
3.
5. Here, 3 and 5. So I'll go with 5. Sort them and then look at them for me. 40 to less than 48? 7 and 4. Whoa. I think 4 is right. How about 48 to less than 56? Don't count 56. This is what? What do you got?
Yep.
3. How about 56 to 64? I think we're in the C range. How many C's?
6.
All right, now we're up to the B range, 64 to 72. Don't include 72.
9.
I heard a lot of 9s. We'll go with 9. 72 to 80, we're in the A range.
7.
7? We got a confirmation on 7? And then the last one is 1. We should add up to 36, right? That's a way to check ourselves if we need to. Okay, we'll just go with these. All right, so what have we done? We created our classes. They all have equal widths. Okay, and then we went ahead and counted up. We created our distribution. We just did that. Remember what a distribution is? It talks about what the variable is, the value of the variables, and how many times they came up. That's what a distribution is. So now we're ready to make our picture, just like you'll see on that page. So how do we do that? It's just the first quadrant. So we're going to draw vertical and horizontal. Yeah.
What were the 4 numbers we had to add to it again?
We added 6 numbers. 38, 37, 57, 64, 62, and 59. All right, so along the bottom here will be our number line. Okay, now, we start here at 16, that's not that far away, but look at that picture. You see how they start here at 0 and then all of a sudden they're at 40? You can skip ahead. You see those 2 little lines they put in there? That's kind of like your skip ahead thing. I don't know that we have to do that here or not, but I will go ahead. So we'll start here at 16, and we'll go by 8s. 4, and this is just a number line. This is all this is. This would be test scores. The vertical axis is going to represent the number of counts that we had in those classes. Well, what do we go? 0 to 10, basically, or 9 is the highest one, so I don't know. I'll go by ones to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the frequency. I think I've called this count before, but quite often you'll hear it called frequency. What's the frequency of time the scores were in that range, in that class? All right, now we just draw our rectangles to represent how many were in each class. So the first one I had just 1. Second one 0. Third one 5. 4. 3. 6. 9. 7. Title on it, you got yourself a histogram representing those test scores. Question: did we lose any information from our dot plots or stem plots to the histogram? Have we lost anything? Yeah.
Yeah, we don't know the exact numbers.
Yeah, we don't know the exact test scores anymore, do we? Remember on the dot plot and on the stem plot, didn't we know the exact scores people got? So we do lose a little bit of information. But remember, if we got 500 scores, do we care necessarily what exactly each one of them were, or do we want to get the general idea from center shape spread and outliers, which is what we get there. So we do lose a little bit of information on a histogram, but it still gives us pretty much what we need. All right, that is creating a histogram on the fly. Our calculator will do it for us. Okay, so let me show you how we can do that same exact histogram, put on our calculator. All right, let's get our thing set up here. First thing I want you to do, go into your y equals button. It's over there on the top left. All you calculus freaks and whatever, you guys maybe have an equation in there. Get rid of it. So if you've got an equation in your y equals, get rid of it, or otherwise you'll see some line come through your histogram, which you don't want. All right, let's go into stat plot. It's the top left button. So you go second, y equals. You may have some graphs on right now. Turn everything off. Go down to 4. Make sure we got everything turned off. And let's go back into the stat plot. They all should be turned off. And let's go in and create a histogram. So if I press the number 1 or enter right now, I get to this screen. I'm in plot 1. Let's go ahead and turn it on. So if you hit enter when it's on a certain spot, it will change it. So we have turned on plot 1 now. These are the different graphs that we can make. We're going to learn all of these. That's the good guy right now, right? That looks like a histogram. So you can use your arrow key, go down, go over, then hit enter. All right, X list. The calculator is saying, hey, what numbers do you want me to use? I'll draw you a picture. Tell me where your numbers are. Ours are in L1. Tonight. Tonight's homework problems you're going to do, they're in your L2 right now. We got a head start on your homework right now. So they're in L2. So right here you would do L2, second 2, so it would make it L2. Okay, but we're using L1 right now. Frequency, I don't know what that means. We'll figure that out later. All right, let's go ahead then, and what do we need to do now? So I want to make this graph. So what else do we got to tell our calculator about?
Classes.
Yeah, your calculator doesn't know any of this stuff. Calculator's got to know, okay, where do you want to start? How much do you want to go by? We do that in window. Go to window. It's on the top row there. It says window. Now you might have some crazy stuff in here if you did some graph before like I have. We need to change this to look like the classes that we set up. So window is setting this up. So where did we start? What's the x minimum, right? This is the x-axis, so what's the x minimum? So put in 16. Where are we going to stop? 88. What are we going by? Well, we went by 8s. Now, the y is this. How do you want this set up? Well, we started at 0 and went to 10, didn't we? So we can go ahead and do that, 0 to 10. And we went by 1s. You know, if this was 0 to 1,000 and you wanted to go by hundreds, you'd put, you know, hundreds there where it says x scale. But we'll just go by 1s. All right, we should be all set up. Just hit the graph then. The far right key on top, blammo, is that the graph that we did by hand? Now you're going to create a couple of histograms tonight for your homework. You're going to do it the old school way. But eventually, you're going to be allowed just to put this on your calculator and then just put it on your paper. All right, we had a lot of decision making to do when we did this. I wanted to go by grades and whatever. Your calculator will create a histogram for you from scratch. Okay, let me show you how to do that. So if you go to Zoom, and all the way down to the most important zoom, which is obviously zoom stat, number 9, and hit enter, it does the whole histogram for you. Uh-oh, wait a minute. Something's wrong here. It's not the same histogram we did. Isn't it different? Doesn't it have kind of a difference? Why? Why is that not the same histogram that we just did? It's the same numbers. It's in L1. How can that histogram possibly look different? I don't understand. Why is it different? I mean, it's kind of close, but why is it different? Yeah.
Is it because the classes shift?
Yeah, the calculator did this. It set up different classes. If you want to see how the calculator set it up, go back to window. That's how the calculator said was a better way to do it. It says, hey, we'll start at 22. We'll finish at 90, and we'll go basically by 9.8s. Okay? So, you know, that's if you want to just take a quick look at a picture and let the calculator do the work for you, it's fine. But I wouldn't want to go by 9.8s as I was doing that, plus it doesn't match grade. So, if you can either set it up yourself how exactly you want it to look, or you can let the calculator do it for you and start from there and work backwards. Okay. Questions? Histogram? Yeah.
Mine isn't showing up.
Okay, just if you have individual issues, just come show me and I'll work with your calculator. Anything else about what a histogram is, how to create it? All right, now, back to the old days, center shape spread outliers. We can do it from this histogram. Center, looks like around here. Shape, I think we kind of, on this picture, it looks like we've got 2 bimodal. The other one we did with the different classes actually looking at more unimodal, so that's interesting. And that's just like your single and double stem plots you were doing, how the pictures can look different if you spread them out more. It's the same idea here. Spread, we definitely see a gap here. Okay, you can talk about the minimum and maximum. You go back to the real data and get your minimum and maximum and all that kind of stuff. But you can see gaps and clusters. There's definitely a cluster in this area. And outliers, once again, looks like there could be a potential outlier over here, and there's your 22. Yeah?
So when we're describing center, do we just say between?
If I'm just using the histogram, in other words, I just give you the histogram and I didn't give you the data, yeah, I think you'd have to say it's, well, I would say around 64, maybe a little less. You know what I mean? I know there's a bigger one here, but this stretches out a little bit, so.
So do we take the max and min from the graph? Or the
If you have the actual data, then you go get the max and min from the data.
Okay.
Okay, to get your range, to get your exact range.
Yes.
If you just have this, you're going to say there's a minimum between 16 and 24 and a maximum between 80 and 88. That's the best you're going to be able to do. So you're not going to be able to find an exact range that way. Okay, let's get a little bit more specific about shape. All we've been talking about now is, you know, different peaks and stuff. We're going to through some more vocabulary words at you. You're going to be a little bit better at how you describe what the shape is. All right, same idea here now. You know, you're going to draw a rough kind of picture over what you've got. And that's what you see here with these rough pictures that I've got here. Symmetric. Symmetric means, you know, if you put a mirror down the middle, one side of your picture and the other side of your picture would look about the same. If you have a situation like that, you would say your shape is roughly symmetric. Some examples of what some symmetric ones would look like. This one. Kind of looks the same both ways. That one, that's got two humps, but right, if I put a mirror down the middle, doesn't it kind of look the same on both ways? So those are two examples of shapes that you would call roughly symmetric. So it's either going to be symmetric or skewed left or skewed right. You got to understand the difference here now. When I'm drawing this picture, when I have to, from the major mode, go a long way over here. This is called a tail. When the tail has to go a long way over here, that means I had some really small number out there. So that tail had to go way over here to get to that small number. We call that skewed left. The longer tail, and if you have a small number, it's going to go way over there. We refer to that as skewed left. I need you to understand why this tail was long. Oh, we had some really small test scores compared to where the other ones were. Same idea on the other side. Let's say you got your majority of scores here, you got yourself a cluster. And then your tail, when you draw the thing, comes way out here. But on the other side, it just kind of comes down. It means we had some really, really high scores. The tail was longer to the right side. Therefore, it's skewed right. So you're going to be one of those three. You're going to say it's roughly symmetric, or you're going to say it's skewed right or skewed left. So what would you say on that guy? Yeah, it's pretty skewed left. Yeah. What about this guy? All right, now wait a minute. We don't have skewed up and skewed down, right? So you got to make it into a horizontal deal. But which way would you go on this one? I'd say slightly skewed left. Yeah. You know, it looks, this tail is going to be, that old 5.5, that tail got longer over here than it was to get to here. Now, if I took that guy off, yeah, roughly small skewed right. Took them both off, maybe a little bit skewed left, but you could almost say roughly symmetrical here too. Okay? So those are the words I want to hear now when you're in shape. Modes, we talked about that already. You got one hump, that's unimodal. You got two humps, that's bimodal. Three humps, go trimodal. If you got more than that, make up a word, multimodal. Okay? Any questions at all?